Maybe I can use this. Okay. Yeah. I think I'm not very good at state of technology like this. Taiwanese computer. Taiwanese computer is much better than Korean, I guess. That's why I cannot use Taiwanese computer. Samsung is not that as good as some Chinese electronic companies. Anyway, that's good. Okay, that's perfect. Anyway, I don't have enough time, so I want to give you the big pictures and then process, and then some of my experiences and implications of this kind of job. There are a lot of ways to look at the future, but in climate change policies and scenarios, usually, especially in Korea, we are looking at 5 big trends. First one is economic growth and industrial change, and then population, energy and greenhouse gases, and land use, and finally climate itself. As you know well, in 10 or 20 years, maybe we can use our scientific knowledge and our methodology, some rigorous and sophisticated one. But if we are talking about 100 years, sometimes we need to be more than beyond scientific knowledge. It's kind of some kind of imagination and some kind of artistic view of the future. So I will talk about a couple of things like that. Basically, establishing scenarios, especially for the very, very longer term, we need a lot of data and a lot of works, a lot of research papers from other legitimate and important and very excellent institutes. So we collect a lot of basic and important scientific literatures and expertise, opinions, things like that. And secondly, we try to establish a very rough picture of those 5 factors. And then we have some sub-expertise group for each factors. And then finally we have some consistent and then very well organized final set of scenarios. These scenarios are used for other following specific research works in whole project, such as agricultural activities, ocean, and some macroeconomic effects, things like that. And then we have some fundamental views for the future, climate-related in Korea. Which areas are the most influential? When we talk about climate, every factors are interrelated. All factors are involved. However, when we're preparing for policies and preparations for the 90 years or 100 years, we need to find or we need to prioritize which factors are most important. And then we break down drivers and some trends and factors, things like that. So each trend has drivers and some specific factors, some specific elements. That's what we did. And so if you look at this kind of complicated picture, we decided 5 big drivers: population, economy, and then finally climate. And we tried to get some elements like for population, birth rate, and expectancy, life expectancy, things like that. And for energy and greenhouse gases, some supply side and demand side energy structures in the future. Okay. And then this is our work kind of operation map to proceed this kind of work. We planned, in my experience in this work, planning is very important in the first stage. Planning, discussion. Without you need some time and effort to pour. Without well-planned, schedule for this, it's not easy because there are a lot of things involved in scenario establishment. So this is the basic procedure. I mean, the framework for the scenario and some expected results is some part is pretty much obvious, but some part is quite surprising result in this work. If you look at the last sentence, in Korea, maybe in other country in similar like Korean economic and social development, economic will grow, but in the very long run, maybe some big decreasing rate, like currently what Japan and then European countries are experiencing. And then land use basically is pretty much influenced by policy decisions. Land is climate is very tricky things. One of my colleagues in other seminar told me climate change itself is climate change. It is the problem of global problem. However, the response it should be local. So it's a very international public economics or public theory should be involved in there. So that is very tricky things. Anyway, the climate in Korea is the temperature will increase, precipitation will increase, but the seasonal variation and season may change it. Maybe we are experiencing right now. And then the greenhouse gases is pretty much depending on technology and energy supply structure in the future. That is the basic results I'm going to share with you today. Okay, let's go for climate first. As I told you, climate itself is global one. Even the small, very little change in Korea is, I don't want to say butterfly effect or something like that, but still climate is very holistic all over the global things over here. So we collected a lot of data from international institutes like UNFCCC and WMO, and then some KM, Korea Meteorological Association. Anyway, and then we try to sort out the best possible scenario from those important information, and we decide A1B is one of the best possible and best appropriate scenarios for that. And then we downsizing, I mean making more delicate and sophisticated resolution, especially for the area for the Korean Peninsula. If you look at this, the temperature is increased last almost 100 years. And then this some picture for A1B scenarios, Korea temperature change and precipitation. And we narrow down like this. So in terms of temperature, the Korean temperature in the future will increase compared to last 3 decades on the average. The first 50 years, maybe we're going to experience 2 to 2.3 degrees on the average. But at the end of this scenarios period, year 2090, it's going to be almost more than 4 degrees Celsius a year on the average. So it's a big one. However, make our climate, temperature scenarios is more important, is change in seasons. Korea is very famous in 4 distinguished seasons, from spring to winter. According to our results, the seasonal variation is getting closer and closer, and then we may have only, in extreme case, just 2 seasons, summer and winter. The spring and fall is getting shorter and shorter. So that's one thing. If you look at the second graph carefully, we can see the shorter spring and then shorter autumn in the future. Anyway, In principle, rainfalls. Korea is also a kind of a big rainfall country. However, and the other thing is Korea is famous for some the monsoon season in the future. I mean, in late summer and early September. So usually late August and early September we have some big monsoon seasons. However, according to our results, the rainfalls, especially the monsoon seasons, getting longer and longer. So almost at the end of this scenario time, from June to September, we may experience the big monsoon seasons, which we never experienced, which we have to prepare because there are a lot of costs involved in there, some flood things and then other kind of climate change things. And then I'm going to make it a little bit past to this one. Finally, in climate, the humidity, obviously, because of increasing temperature, and then humidity, relative humidity, will increase too in the future. Maybe 2 to 2.5%, 2 to 2.3% in the future. The second driver is economic factors. It's kind of hardest one because most of the economic model is talking about less than 20 or sometimes even the longer term is 30 years in the future. However, since climate change is very, very closely related to industrial activity and economic growth, we try to make kind of audacious. It's quite daunting task to do. Anyway, we have some short or mid-term economic models, 77 sector models in Korea. And we have capital and labor for those sectors, and then some technology and productivity change in the future. However, we have to extend that thing up to the year 2100. So we need a lot of mega trend analysis. For the very longer term economic forecast, we need mega trend, like what kind of technology, like fusion technology is best possible, or labor and capital, the relationship might be changed. The production function itself might be totally different. But we cannot make it just a simple story. We need some logical foundation for that. That's why we have some futurologists in our economic and industrial change groups in the future. Anyway, so according to the economic and industrial drivers forecast, from now last 10 years, Korea the average economic growth rate in real term is 5% a year, something like that. But in last 50 years, it's going to be 2 point something percent, like 2.3 and 2.4. So it's decreasing. However, after year 2050, the economic growth rate is getting very, very much slower than the previous years. It's less than 1%. In our basic scenario set is 0.6%, which is much lower than the current European economic growth rates. I guess it's pretty much reasonable because in 50 years, the Korean economy is growing, I mean, in very big size, like size of Germany or Japan. So even less than 1% is pretty much big one. The other important thing is we don't think the manufacturing activities in Korea is sustainable forever because we have a lot of competitors. Definitely Taiwan is a big competitor, I'm pretty sure. And China, Indonesia, India, and every country in the world. So inevitably, the Korean industrial activity and industrial structures is more like some service industry oriented in the future. And in addition, manufacturing itself might be change in internal structure. To make it simple, chemical industry today might be totally different the chemical industry in 50 years or in 100 years. Actually, we are experiencing, we found, in terms of infrastructure and in terms of technology involved in there. Anyway, so if you look at this, agriculture and fisheries currently is not a big share in Korean economy, but in the future it's getting smaller and smaller. It's a negative, mining, of course. And manufacturing is still growing, but with a lower rate. And then service is growing much faster than any other sectors in the Korean economy. That's why, if you look at this, currently, number 1 is 2010, 2 is 2030, 3 is 2050, and 4 is 2100. Currently, service is less than 60%, but in 90 years, it's going to be up to the more than 70%, which is very similar like current service share in the United States, I guess. And then manufacturing is a lower 20% compared to almost 30% right now. So somehow we have to prepare some subsidized industry or structure in Korea. And these changes affect on greenhouse gases emissions and energy consumption. It is closely connected to. Anyway, energy and greenhouse gases. We use, as I told you, some of technology and then some systematic, some interrelation in factors and everything. And then one of the hardest job, maybe some of our Taiwanese expertise also experience like that. The most, hardest things in energy consumption and greenhouse gas emissions is technology forecast. What kind of technology? What is maximum technology we can use? And on what degree we can apply those technologies? What the penetration of those technologies in areas? So we have to depend on a lot of legitimate agencies focused like IEA, EIA, some Japanese energy industries, and some expertise in electricity forecast. However, maybe I have to change my forecast again because since Fukushima in Japan, the nuclear power generation has big debate again in Korea too. So we have to review the new story, the cost and then the risk management of nuclear power plant in Korea. Anyway, basically, So we use IEA, and especially big information for electricity generation. And then the recent report, actually, I met some of expertise in IEA. They visited Korea year 2011. And the technology perspective, some of stories is very important, establishing technology maps, energy technology maps in this research. And then EIA is also very good views for the future every year, which is U.S. Energy Information Agency. And then Japanese Energy Economics Institute is also gave us a lot of good, insightful information about new renewable energy sources. Anyway, so according to there are hot debate actually how long the fossil fuel will be competitive and sustainable and available within Korea. But in the basic idea is like this. Maybe after year 2030 to 50, the fossil fuels price and availability in terms of shadow prices are very, very increasing higher. So the fossil fuels will decrease in its share and in real term too. However, we need a lot of electricity with renewable sources to support the expected economic growth and industrial change I told you. So according to the result, all fossil fuels will decrease in a certain amount, between 1.2 to 1.7 in coal case. However, all those decrease in fossil fuel use, we have to try to find and try to get from renewable energy resources via electricity. And then these CO2 emissions from those activities. If you look at the total, I'm sorry, it's year 2010, not 2001, the left, the second, row over there. The greenhouse gases increase up to 900 million. However, it will decrease because of a lot of renewable energy sources. This is 430 or something. So maybe I'm gonna talk about this one again. There might be, in basic scenario in Korean economy, energy and greenhouse gases and socio-economic variables. Definitely, it will experiencing some decoupling in those two factors. I will show you at the last slide of this presentation. Make it briefly. Population and then land use. Population and land use, they all are some big questions and issues. And then make it things, in my experience in this research work, population is kind of very extreme scenarios are possible. One scenario in Korea. Korea is very famous for the lowest birth rate right now in OECD countries. So one scenario says, in the future, the Korean population is getting smaller and smaller, extremely. I mean, jokingly speaking, one of my friends who is the sociologist is talk about, in 300 years, in the earth, there is no Korean anymore, according to mechanical model. Please try in Taiwan. I don't know the birth rate in Taiwan. But it's possible. I mean, 300 years, 400 years. But it's a very mechanical models over there. There might be some kind of change in trend, like France experienced in 20 or 30 years ago. Things like that. Anyway, we try to put this, debatable issues in a rational way as possible as we can. However, still, the South Korea, the population will decrease in the future. If you look at this one, currently Korean population is 48 and 49 million, so slightly less than 50 million. However, it will be the peak somewhere near year 2020 and 2030, almost 50, and then it will decrease 42 to year 2100. It's going to be around 40 million. Say it's some big amount. But my other scenarios, which said we may sustain 45 to 50, things like that. So we have to review consistently, but still we have some extreme debate for that. Birth rate and the change in attitude to raising kids, and then other things involved in educational costs, things like that. So anyway, our best possible estimation is only 40 million or something like that. So Korean population is getting a little bit smaller than previous level. I'm pretty sure when in Taiwan, or if you are doing a couple of jobs like this one, the population is most debatable area in longer term projection. So if you look at this and then make more difficult in this progress, in this area is the very old age groups shares. Currently, the age groups over 65 years old, according to Korean sociologists, this kind of elder groups in population structure, demographic structure, is less than 10%. But year 2050, it will increase almost 40%. Year 2100, it's almost 41 or 42%. Now, this is a really big implication in socioeconomic and also in energy consumption and greenhouse gases. So, that is the findings we have in population. And finally, land use. Land use is also is very tricky one, but fortunately, maybe for the researchers like me, Korea is not that big country. And then we found most of land use in Korea is basically influenced by policy decision. Do we use this land for agriculture, or do we use for this habitat or road or things like that? The findings in this area is we need more roads. But agricultural land, if you look at this is percent term. Farmland is getting smaller and smaller. Forest is tricky. Forest is slightly going down first couple of 10 years, decades, and then it will increase in the future because of forestation and then decrease in population and then change in industrial structure, rather from over service industries, will affect this trend. Anyway, there are a lot of things to talk about, but I have to wrap up my presentation. This is the simple, however, basic idea, what we look at the future, climate change related factors in Korea. So I make this one in index, all those 6 couple of important factors. So if you look at this one, the simple idea is like this. Economics, growth, and then industry, it will increase. Say from year 2007, if you look up, the economy will grow, say, 4.7 times than now. That is value, actually. However, CO2, greenhouse gases, electricity, and energy, it will increase, but not as fast as population. It will decrease, basically. So, in basic model, without any aggressive policy involvement in there, still economic growth, but materials growth, but very, very, very lower rate than economic growth. So that is definitely decoupling economic activities and energy and greenhouse gases. Then does it mean we solve the problem? No. That's why we make this kind of decoupling effect a little bit bigger and bigger. Say sustain, say, less than 2 degrees or 450 ppm scenarios in the future. This is not can be done by Korea itself, but all global countries, we should work together. Anyway, it's such many things, but I have to stop here. Thank you so much for listening to me, and this is the end of my presentation. Thanks a lot again.